Let's work on this next inequality here. We want to begin by isolating the absolute value on the left, which means we want to subtract 1 on each side. This will give us 2 times the absolute value of 7 minus y is less than 16. We next divide each side by 2. We now have the absolute value of 7 minus y is less than 8. Because we have an absolute value with a less than, when we remove the absolute value, we will form a compound inequality. Negative 8 is less than 7 minus y is less than 8. We then subtract 7 from left, middle, and right. This will give us negative 15 is less than negative y is less than 1. And when we divide each side by negative 1, we need to be careful to change the direction of the inequality. So we will have 15 is greater than y is greater than negative 1. But again, we do not like writing our inequalities from large to small, so we're going to rearrange this so that the negative 1 is on the left. Negative 1 is less than y is less than 15. Writing this in interval notation, we have negative 1 to negative 15, in which we do not include either endpoint, using a parentheses. Now we want to again isolate the absolute value, which means we want to subtract 6 on each side. This gives us 9 is less than absolute value of negative 2d minus 3. I think I want to rewrite this with the absolute value on the left-hand side. This will be the absolute value of negative 2d minus 3 greater than 9. And when we have an absolute value with a greater than, we create two inequalities. Negative 2d minus 3 is less than negative 9, or negative 2d minus 3 is greater than 9. And we solve each of these inequalities separately. We're going to begin by adding 3 to each side. So negative 2d will be less than negative 6, or negative 2d will be greater than 12. Then, when we divide each side by negative 2, we're going to change the direction of the inequality. And this will give us d is greater than 3, or d is greater than, let's make that less than, negative 6. Okay, let's take a look on a number line at what this looks like. We have negative 6 to the left. We have 3 to the right. Okay, we're looking for the word or, which says join these two together. So this is not a no solution problem. Instead, we will have from negative infinity up to negative 6 united with the interval from 3 to infinity. Let's solve each of these sets. We have an absolute value with an equal sign, so that means c minus 3 is equal to 0, or c minus 3 equals negative 0, but that doesn't make any sense. So basically here we have c equals 3, and 3 is all that is in our solution set. When we move on to the second part, we have an absolute value which is positive less than 0. That right there is not possible. You cannot have a positive number which is less than 0, and so part B is going to yield the empty set. In part C, absolute value means the left side is positive. It cannot be less than 0, but it can equal 0. So basically, this is the same as what we had up in part A, where c minus 3 is equal to 0, and we have a solution set of 3. When you have c minus 3 greater than 0, we're going to write as two inequalities. C minus 3 is less than negative 0, which doesn't make any sense, so we just write 0, or c minus 3 is greater than positive 0, which is just 0. So we have c is less than 3, or c is greater than 3. And in interval notation, this would be from negative infinity up to 3, united with the interval from 3 to infinity. In part E, pretty much the same thing as part D above, except we're going to be including the 3 at both endpoints, and so now we don't have this gap in the center, and we will have all real numbers from negative infinity to infinity as our solution set.